Hi, sixth graders. So we're starting a new topic today, and that topic is called congruence and symmetry. All right, so let's first look at the definition of congruence. So congruence means the same size, same shape. So if you're thinking about even just, let me pan the camera over here a little bit. If you just think about the tiles on a schoolroom floor, right? I'm just showing you the floor here at school. All of these tiles, no matter their color, or you know, some of them are white, some of them are black, they're all the same size and same shape. And so that's what we mean by congruence. It just means the same size, same shape. And so, for example, the tiles on the floor, or let's just draw an example of a couple of triangles. So I'm going to draw a triangle that looks like this. You can use your artistic skills best as you can. I'm going to try to make them the same size and same shape. You may have to use your imagination a little bit, but that's about as good as I can get it. So same size, same shape. And there's a symbol that we use for congruence, and it looks like this. It's an equal sign with a squiggle on top of it. That's the symbol for congruence. And so when we're talking about triangles, we can name these triangles. We can give them names by labeling their corners or vertices. So we're going to call this corner A. We'll call this top corner B, and we'll call this corner C. And then we can also give this triangle a name. We're going to call him D, and then E, and then F. And so when we're talking about congruence, here's what we mean. We mean that these are exactly the same size, exactly the same shape, which means that their corresponding sides are also congruent. So we use a marking that looks like this. And so we would say that side AB is congruent to DE. Notice I'm going from bottom to top. So AB is congruent to DE. We would also say that BC is congruent to EF. We're just sort of matching up the sides. And because they're different than this side, I would use 2 marks to mark this side as congruent. And then also, if I say AC, so this is the bottom side, side AC is congruent to DF, because they are the same size, same shape, but they're different than the others, I'm going to use 3 marks. So that would be marking the similar, the congruent sides. And so when I make a statement saying that this triangle, so I would name this, and I'm going to draw a little tiny triangle over here and say triangle ABC, is congruent to, meaning same size, same shape, triangle, and notice I'm going to go in the same order, ABC is congruent to DEF, so triangle DEF. Same size, same shape. Now, it doesn't matter if things are turned. So, like, let's look at another example of congruence. You know, here's a square, and then here's a square, but it's going to be kind of turned on its side. Those would still be, this is still an example of congruence. They are the same size, same shape. It's just one might be turned a little bit. So that's still an example of congruence. Or you could have, you know, let's say a circle and another circle exactly the same size, same shape, but maybe this one's a different color. Like maybe this one's colored in and this one's not. They're still congruent. Doesn't matter the color, doesn't matter how it's turned, as long as they are the same size, same shape. Now, related to congruence, we have this word that is similar. So the word similar means the same shape, but not size. So for example, if you have a large square and then a baby square, those would be similar, but not congruent. They do not have the same size, but one's, I always think of similar as sort of like one's the baby version. It's the same shape, but a different size. And it doesn't matter if it's turned. So again, you could have, you know, a circle and a baby circle. Or you could turn something. So let me draw like a triangle here. and maybe a triangle that's the same exact triangle. It's a baby version of this one, but it's turned. Those would still be similar. So same shape, but not size. One is the baby version of the other. Those would be what we call similar. Now, we can also have shapes that are neither, right? You don't have to write this down per se in your notes, but you know, if you had a square and a rectangle, those would be neither. They're neither congruent nor are they similar. They're just not even the same shape. Not the same shape, not the same size. And so we can also have things that are neither. All right, so that is congruence and related to that similarity. Then the last thing we're going to talk about in the notes today is symmetry. So symmetry is when two parts of a shape are the same, separated by an axis. All right, so if you think about, you've probably seen pictures of butterflies. So I'm going to draw my best little butterfly here. And the best way to draw a butterfly is to draw half of it and then to just do a mirror image on the other side, right? So that's about as good as I can get. Now that looks a little bigger, but if you can imagine, butterflies, kind of make these the same. Butterflies are cut right down the middle by their body, right? And the nice thing about a butterfly is that when its wings fold in and out, this side, when I fold it, it would land exactly on top of this side. That's what we mean by symmetry. Now, this axis, we've talked about the X and Y axis in the coordinate plane. The axis is that line that cuts it exactly down the middle so that one side is the same or folds on top of the other side. So let's look at a couple more examples of symmetry. If I think about a square having symmetry, think about where can you cut a square where it will fold on top of itself. Well, one way is right down the middle, right? I can fold this side on this side and it will match. But I can also make an axis of symmetry across the middle, the horizontal way, because you can fold the top down on the bottom. You can also cut a square in its corners and fold. You could fold this part down on top of this part, or you can fold this half on top of this half. So a square actually has 1, 2, 3, 4 lines of symmetry, whereas a butterfly would only have one. If I cut a butterfly across the middle here, I could not fold the top half down on the bottom half and it be an exact match. So symmetry has to do with this idea of folding it on the axis in order to make the sides equal. Another interesting example of symmetry is a circle, because a circle actually has a lot of axis of symmetry. So you can cut it this way in half, or you can cut it this way and the top would fold, or actually you can cut it this way. There's lots of lines here. There's actually an infinite amount of lines that you can draw in a circle that would create axis of symmetry, where you can cut it in half and fold. Because a circle is completely round, you can fold all halves no matter how you cut it on top of itself. An example of non-symmetry, or an example that would not be a line of symmetry, would be if I cut a shape, in a way that this half does not fold exactly on the other. So this would be an example of not symmetry. If I could spell correctly, S-Y-M-M-E-T-R-Y. So that's an example of not symmetry. All right, so those are your examples. This is a pretty straightforward unit of congruence and symmetry. And you're going to practice with congruent, telling whether something is congruent or similar or neither in your first practices. And then you're going to look at some lines of symmetry to tell whether they're actually lines of symmetry or not. And so good luck on your practice. Email me if you have questions.